Hello, I think we're live. How is everyone doing today? I don't think there's anyone particularly waiting here, but at least, yeah, we started the stream, so... waiting here, but... well, that was myself. Kind of hurts to listen to myself speak, to be honest. Let me just post a message here. Welcome to the stream.
Is it Thursday yet?
No typo this time. Yeah, so how are you guys doing? So today we're actually going to continue writing the audio visualizer. This time though, however, I am not actually coding on the Raspberry Pi, just because I've got some issues with GLFW not being able to create a window, and that is possibly because we don't really have a desktop environment on the Raspberry Pi, which I then installed, but because it was only a remote desktop environment, I don't think that the library GLFW recognized it. But yeah, we're going to continue that today. Oh, there's already someone in here. Hey Peter, how's it going? You doing good today? That's good to hear. That's good to hear. So, you know, it's another evening of coding for me, and hopefully for you as well. Maybe we'll learn something new today. Who knows? But yeah, I mean, what I did learn yesterday is that GLFW is actually contains a memory leak if compiled for the WSL ecosystem. So it's very interesting actually, because when I create the window here, I mean the only code here is that the window creation and the function that destroys it at the end being put into the window pointer, which is a unique pointer, right? But when that function runs, I found that, you know, address sanitizer just complains a lot, and I've established that is the GLFW create window that's kind of causing the issue. So yeah, I mean, we're gonna try and kind of see if there's anything that we can use. I know there's FreeGLUT, that's an alternative library that we can use, or maybe a nicer window library, although GLFW would be my personal choice. So maybe I can try a little bit harder to fix this issue, although I don't think we're going to be able to, because as I said, the issue seems to be with GLFW create window. So yeah, but that's the only downside for today. So let's start Googling, of course. So GLFW. There seems to be a memory leak in this, in Ubuntu 20.04, which is kind of the one I have. I do wonder what happens if we don't use the unique pointer at all, if we kind of just call this as is in here. Let me turn this on the side a little bit. Oh, no, what happened there? Yeah, if we just actually call the raw API without wrapping it on a unique pointer, kind of like that, what actually happens? So if, what am I doing? So if window is an invalid pointer, we're going to say that we kind of failed to start the window. And just for the sake of testing, let's put 406, what was it? 640 by 480. And my title was window title. Just gonna comment out whatever we had here. And then we just need to call the terminate window at the very end, I guess. So GLFW terminate. Is it destroy window? Destroy window. So if we compile this, we still run into memory leak issues, and we'll see that. So fully compiled. Let's clear the terminal, and then call on a visualizer here. No, we don't. Interesting. So somehow there's a memory leak on my function. And what is it specifically here? So I have established Airflow destroy window. Yeah, I'm not sure whether it's some sort of false positive with memory sanitizer here, address sanitizer, and unique pointer, because you know, if we put a print here, for example, if we say std cout, the window is being terminated, right? If we see this, that means that the unique pointer is calling the destroyer function. However, if we don't see this, it means it's not really being created. I'm getting a phone call here, but I'll answer that in a second. So give me 10 minutes and I'll answer it. It's actually my grandma from Brazil, so I do need to, to answer it in a few minutes. I'll call her back in a second after I solve this issue. Yeah, so let's try and use that now, right? So everything here sounds fine. Window destroyer, returns a void. And let's call it like we were doing before. But we get rid of this code now. Still clean build. So Peter, my man, what have you been doing today? Have you been working today, studying? How was your day, man? If you're still here, assuming you're still here. Visualiser. Yeah, the window is being terminated. Fine. Well, now, why did it not work before? I don't know. Oh, of course. It's because I don't have the sanitizer on. Maybe that's why it didn't work. Maybe that's why it worked. Can we add back that code that we had up here and then see if it actually did work? Yeah, I'm in class currently. You've begun immediately. I received your live. Dude, focus on your classes. Don't worry too much about this live. You should definitely focus on studies. You know, have a, I guess, a brighter future and become a better coder yourself. Learning on some shell permissions today. Nice, yeah. Shell permissions, very important concept. Let's remove the destroy window. I'm gonna rebuild this. Yeah, see, no, it's still there, which means that there is some issues with the glfw library, right? Libasam, malloc, Linux line, unknown module. Huh. However, if now I comment out this function here, and comment this out as well, there will be no issues. So it's definitely looking like glfw has some memory leaks in it. Which is kind of a shame, right? We kind of wanted to use this library to create a window. Let's see if someone's had the same issue. If I comment out glfw terminate, I get the same number of bytes lost, but several bytes that are still reachable. It turns out it is a bug in GLFW. It's been fixed on 3.2 though. I was using. Okay, so which version do I actually have here? That is the question, I guess, right? So my Conan file says GLFW 3.3, which is kind of interesting. See if there are any memory leak open bugs here. Massive memory leak. Let's take a look. I love possible memory leaks in Valgrind. I've seen a couple of instances of this before, which I'm sure. Yeah, so this is kind of what we have in here as well. Like, I'm still seeing leaks on the master, yeah. Yeah, so this is an issue of the library itself, guys. Kind of unlucky, really. Kind of unlucky indeed. Kind of a bummer. Kind of means that we have to disable address sanitizer on a line, I guess. Is that possible? I do wonder. Or disable a file from having the address sanitizer running on it. Is there really no way to disable it on a line basis? Disable address sanitizer per line on a line. What is this? This is in Windows though, doesn't really help us. And also this song kind of sucks. Turn it down a little bit. Yeah, it doesn't seem to have a macro to disable the address sanitizer. Leaks is no longer present in this. Again. Yeah, 3.3 is the one I have, so it's kind of the same, I guess. And it's, in my case, it's not even on the GLFW glue. A GLFW init. It's 100% on the kind of like window creation. Because if I run this, where we only have GLFW init and terminate, then it seems to work. It doesn't find any errors. Yeah, I think the best thing we can do here, because this library is a little bit, I'm gonna be honest, a little bit shit at the moment, because it has a memory leak in it, and our kind of continuous integration here has address sanitizer. We just have to find an alternative, right? So GLFW alternative. I mean, I could bring Qt in. I don't really want to bring Qt in, it's too big. This gives a complete 2D graphics library. Yeah, I mean, could use FreeGLUT then. It's a very old library though. GLF. This is GLUT. Screen applications, but Java provides a means to query the available resolutions. They both differ in time queuing, but GLFW offers much higher resolution timers. FreeGLUT timers only have millisecond resolution. What's the difference between FreeGLUT and GLUT? Based on the GLUT API, many servers out there. Designed from scratch with experiences of other frameworks in mind. GLF provides, okay. Yeah, we just need a library to create OpenGL windows. I don't really like FreeGLUT. I have kind of used it before. So I do prefer GLFW, but we need to find something else. To create Windows C++. Not only that, we need an OpenGL window, right? And GLFW, as you can see, is the one that we want. I do wonder if perhaps we can just get a lower version that doesn't have that bug in it, and we can see GLFW. Let's see the versions that we've got. Let's go to 3.3.2 and see what happens. I mean, that is the earliest version they've got, which is unfortunate, but what can we do? Probably going to build a library from scratch. That's fine. So we've got glitch, we've got Qt, we've got SDL, WX widgets. I've not heard the name in ages. Look at GLUT. Yeah, supports newer mobile. LibApril, what is that? LibApril. Let's take a look. LibApril. Hello, sir. Hello, Suyash. Welcome to the stream, man. How is it going? How is it going? I have no idea what this is. What the hell is this? SourceForge. Someone's random library. Yeah, I don't know which one I'm going to choose, because I've established that GLFW is kind of broken. Not broken, but it has a memory leak in it. And since we're building with memory leaks enabled, we don't really want to disable it just because of GFW. So I think we're probably going to go with GLUT. GLUT is the next best thing. So yeah, let's get that. Let's grab that from Conan. But just one more test though. I think we have got everything here. So I want to kind of just compile it now with a new GLFW version. And I kind of want to see if it still works. I don't think it will, right? So it will complain about the memory leak. SRC. And we've got audio visualizer, right? No. Unix build. SRC audio visualizer. Yeah, see, it still complains, and this is just the create window function. Seems to have a memory leak in it. Not a problem. Let's go for FreeGLUT. Let's go for FreeGLUT and replace that. So alternative toolkit GLUT library. So let's see what this is going to bring us, because I've not myself got a lot of experience. I've not got a lot of experience myself with FreeGLUT, but I know that it's very simple to use as well, and we can probably just grab the code online. FreeGLUT. Let's put that there. Let's go back and then run Conan install again. And we're going to build FreeGLUT. Now, what happens if this library also has a memory leak in it? I have no idea. I have no idea what we're going to do. At this point, we're just bringing Qt and then try to keep it as light as possible by just creating a very basic window. Qt will have definitely will have no no memory leaks in it. And Conan has finished pulling my third-party dependencies, and now what do? I need to actually look at the find GLUT files and then just see what kind of targets we have here. So fmt, oh no. Find GLUT.config, target debug. So it seems to be FreeGLUT. Okay, yeah. So we can include it on a CMake. Right. It's gonna be a slight shift to our plans today, but what can we do? Now let's see, FreeGLUT, GLUS. Find FreeGLUT, it's not available. Oh yeah, it's not, because I've given it a different find GLUT, it should be. Jesus, why is this not finding it? There you go, found a lot more stuff now. So, okay, library detected. So that's what we have to link against. GLUT, kind of like this, GLUT. Now, of course, we no longer have GLFW. We have GLUT now. Right, we have GLUT here. Let's look at some code snippets. So we can basically just copy and paste some code now from GLUT. Is there an example on that page? You can see it's a very, very old library because the website is very, very old. They have releases here, never mind. Last release was on October 2022, just under a year ago, I guess. So There you go. FreeGLUT is what we want. And then we're looking at this nice tutorial by this person, OGL Dev. I don't know who this is. Thanks to Mariano, silly guy. You can read this, but that's not the person who wrote it, that's just the person who translated it. I'm crediting the wrong person, but that's fine. So we need to initialize GLUT. Okay, that is fine. And apparently we also need the argc and the car**argv here. And we need to do GLUT init, is that right? argc and argv. That points to an integer argv. Right? argc. Now what does this return to us? It returns void, so it doesn't really do anything. Right? It doesn't do anything. Cool. Just initializes it. This calls initializes GLUT. The parameter can be provided directly from the command line and included, such as sync and GL debug, which disables the synchronous nature of X and automatically checks GL errors and displays them respectively. That's good compared to FreeGLUT, I guess. You have to register a callback. So it shows the errors if we have GL debug. That's cool. This is definitely going to be something useful though. I can see myself running this a lot. But anyway, so GLUT init display mode, GLUT double. So here we configure some GLUT options. GLUT double enables double buffering, join to a background buffer while another buffer is displayed. That's probably, you know, what we're going to go for. It's the usual thing on the color buffer where most rendering ends up. Okay. We will usually want these two as well, as we see later. So we want, I don't know what GLUT RGB does. And I guess we enable depth checking, like Z buffering, I guess. Is that right? With this, so let's go for it. Like, why not? We're basically just going to copy line by line, but I also want to read this tutorial to kind of understand what these GLUT functions are doing. So May 2022, one of the viewers of my YouTube channel informed me that he wasn't able to activate the depth unless GLUT depth was explicitly added to the above call. On my machine, it works correctly even without the flag. Okay, yeah, well, it doesn't hurt to be explicitly adding the Z buffering, I guess. That's what it is, right? The depth checking in OpenGL. So GLUT init window size, GLUT init window position, GLUT create window. These calls specifically create window parameters, and you have the option to specify a window. Right, cool. Yeah, let's just copy this and paste it onto our code here. And then maybe, did these return anything, by the way? Void, void, void. Oh, int. Okay, so what does this return though? GLUT create window. GLUT create window. Let's see if we can get some documentation somewhere. So what does this do? Usage. GLUT create window name. Okay. Current window is set. The value return is a unique small integer identifier for the window. The range of allocated identifiers starts at 1. The window identifier can be used when... Okay. So is it safe to say that if it returns a 0, in other words false, it didn't create the window? Yeah, I guess we can try that, right? We can see. So we can do something like window autoconst window ID or something. GLUT create window. And instead of tutorial, let's call it, I don't know, audio visualizer. Even though we have nothing about the audio visualizer yet. In position, that's fine. GLUT init window size. Okay, I'm fine with that as well. Yeah, this is just to clear the color, GL clear color, GLUT display function. These calls specify the window parameters and create it, you also have the options to specify the window title. Okay, so GLUT display function, what does this do? Since we are working in a window system, most of the interaction with running the program occurs via event callbacks. Okay, GLUT takes care of interacting with the underlying Windows system and provides us with a few callback options. Here we just use a main callback to do all the rendering of one frame. This function is continuously called by GLUT internal loop. Okay. Okay, so what should actually go in here though? So I guess a render function, right? So GLUT display function. Let's just call that for now. First of all, let's just make sure that if window ID is more than or equal to 0, we can say that we didn't create the window, right? So that's the CL window was not created. And then we can return -1 from the program. And then we can call the display function. That's not what I meant to do. GLUT display function. Now I need to make sure that I know exactly. Takes a void and returns a void. Right, so this is an interesting function. It takes a function returning void and takes in void. We can just create one for now here. Again, we don't need these anymore for now. What we do need here is a function that returns nothing, and it's called something like, you know, render callback. Just so we can understand what's going on, we can just put a print inside it, so whenever this function gets called by GLUT, we will know. And clear color 0, 0. Render callback. Now what does this return? A void as well, so it doesn't return anything. What I don't like about libraries, I don't like when libraries don't return like an error status or something like that, because, you know, especially when you have to like to set a callback to like check what the error is instead of just returning the error. Like, this GLUT library seems to be one of those. But anyway, and then it's just a function gl clear color to clear the color, I guess. This is our first encounter of concept of OpenGL. Okay, yeah, we know about that. The idea behind status such as complex X cannot be treated as a function call. Correctly designed functions never receive a lot of parameters. You don't need to specify shaders, buffers, and various flags affecting how rendering will take place. In addition, you would often want to keep the same piece of configuration across several rendering operations. If you've never disabled the def test, then there is no point in specifying it for every render call. That is why most of the configuration of rendering operations is done by setting a flag and values to the OpenGL state machine, and then rendering calls themselves are usually limited to the very few parameters that revolve around the number of vertices to draw and starting offset. After calling a state changing function, that particular configuration remains intact until the next call to the same function has a different value. Yeah, the above call sets the color that will be used when clearing the buffer, described later. The color has 4 channels. Okay, yeah. Yeah, so basically this whole text is just saying that you should view OpenGL as a state machine, right? So you set the states with a different function call, such as GL clear color, as you can see here. And then when you actually do a GL render, or whatever it is, GL draw, that's the one, or swap buffers, then that's when it gets kind of drawn onto the screen, sorry. The call has 4 channels. So this call passes control to GLUT, which now begins its own internal loop. In this loop, it listens to events from the Windows system and passes them via the callbacks that we configured. Ah, okay, so this callback isn't for the render, it's just for the events, right? So this should be an events callback. The name is kind of a little bit confusing. Again, we don't need GLFW stuff anymore. Though we have one too many parameters, we do. Okay, so GL clear and GL swap buffers. I'm not exactly sure whether this person meant to put all these functions in this order, but we are copying them in the order that we see in here. So GL clear and then GL swap buffers. There usually be like a while loop in here, so while like true, we render forever basically, so this is the render loop or the game loop. And in fact, I guess most of these, like GL color clear, would go here, and then GL clear would happen after that. And then GLUT swap buffers to swap the back buffer with the front buffer, you know, making sure that the thing renders. And GLUT main loop, that was before the clear. I'm gonna add here maybe to the end of our stuff. Okay, does this compile? Let's have a look. Surprisingly, it does compile. Now, can we open this without running into memory issues? That's the true sort of measure that we're using here. So cd build, Unix, src, audio visualizer. Yeah, we do. And here it is, guys. We have an OpenGL window without any memory leaks. How good is that? I love this. Never mind. We have a memory leak. Why is that though? Is that because we have to basically, in the end, perhaps, yeah, we can listen to the close call now, right? So, sorry, GLUT close window event. So we have the close function. Okay, so this library kind of works with callbacks all the time. So there'll be a callback for when the thing closes, when the window closes. There'll be a callback for when an event happens. I kind of get the interaction with this library now. Close window. Do we have any examples here? Okay, no, I don't want to watch an advert, please. There you go. I'm not sure about you guys, but I hate websites that like basically have a paywall of adverts before you can read anything. And now it doesn't work anymore, so what the hell? It redirected me too many times. So, okay. GLUT close window event. So Slim, yo, hey Slim, how's it going? Good to see you, brother. Welcome to the stream again. So we fixed yesterday's issue by getting rid of a library called GLFW because it had a memory leak in it, and there's a few issues open on their GitHub. So yeah, I decided to change the library to GLUT. So I'm good, bro. That's good to hear, man. Good to hear. Hopefully you had a good day. I don't know what time it is where you are, but for me it's basically very kind of late into the night, nearly. Timer int. So callback render if GLUT get window. If we can't get the window, same time as you. Oh yeah, shit, you're in London, right? I keep forgetting. Yeah, there's some people here from India sometimes, and some people from like Africa, so it's a bit difficult to keep track of what everyone is. But I do remember that you said you were in London just now. Fuck's sake. Alright, bro, what do we need to do here? So basically, we've got a window. And I want to make sure that kind of this terminates. This terminates gracefully without throwing memory issues. So I need to sort of destroy the window. I need to uninitialize or terminate GLUT. But for that, I need to figure out which function, which callback will be called when I close the window. So the GLUT leave main function causes FreeGLUT to stop its event loop. And event processing. After an application has finished initializing its windows and menus, it enters the event loop. Within this loop, FreeGLUT polls the devices, keyboard, mouse, and calls application appropriate callbacks. Cool. In GLUT, control never return from the GLUT is involved. The calling function is prevented an application from having re-engine code in which GLUT could be invoked. Okay. I mean, that makes sense, but I kind of need some examples, to be honest. That's not going to go in my head quite easily. Huh? Can we just get an example? So GLUT window example. I mean, we kind of already are in this one, so. I mean, he goes into OpenGL here. I kind of just want to see what he has in the end of this first example. Shout out to this guy, whoever he is.
On each Linux
OGL dev.
Return a different value which is correct locally. This provides flexibility.
I mean, he's writing the make file.
It's better to check for greater than because of possible floating point. This works fine.
Yes, he's got a lot more callbacks than I do. So
on every frame.
So we've got GLUT main loop. Yeah, so it seems like GLUT main loop doesn't fucking need a while loop because it enters that automatically. So I can do GLUT main loop here. Jeez, I don't 500 subs, bro. 500 subs? Do I have it now? I was not aware. 499. Oh, 500. Yeah, shit. Thank you, guys. Thank you. Yeah, I mean, it's been very long for me to get 500, to be honest, compared to some other channels. But nonetheless, we've achieved it. Let's get 1,000 now, I guess. So, anyway, going back to this. Yeah, going back to this code. Is this the game loop? That's what I wonder. So is this the game loop? We swap the buffers. Okay, let's build it and see what happens. Yeah, it is the game loop because it keeps going forever. So render called. Yeah, this is very different to GLFW in terms of the callbacks. Right, so what is this program doing? So the first example, we use an OpenGL in C. This program draws a classic red-blue triangle. And then let's start from actually a working program and then read the documentation after, I guess. So inits the library. We've got the display mode and the window size. We've got window position as well. We've got the create window. So the display function is display. Okay, so this is, all right, so all my game loops should go in here. So the render function. And I guess, right, all this GL clear and GL stuff should be happening in there, so. So yeah, they've got swap buffers right at the end. This tutorial just doesn't explain it very well, like where you should be putting those calls. Now this is OpenGL kind of OpenGL 2, I guess. Yeah, this is OpenGL 2. We're in OpenGL 3 now, so we have to basically do the shaders or compile the shaders, so we can actually draw some triangles. So that's what we're going to be doing here, right? So. Now the question is, does this still give me a memory leak? Because I think it will. So let's take a look. So we've got the window here, and yeah, we still got the all this stuff here. Is it because we have to do a glue terminate? Terminate. What is the function? I return 0. This function does not return. The program ends when the user closes the window. Okay. Glue terminate. Can't exit the main loop and glute. If that's not what we want, you have to use another window library. I think draft up is pretty good. And terminate a glut. Memory user. Yeah, I mean, the glue main loop function generally never returns unless you add custom logic to do so. You technically don't need to free all the resources at the end of the OS reclaims that memory. However, if you want to explicitly clean up, you can call glute exit in glute close function, or add a custom exit handler to this. Yeah, so these people have the same issue as me, where they have memory sanitizer enabled, and they realize that when you exit the program, it doesn't actually exit gracefully. I mean, it doesn't release all the memory. Close function, there is an immediate seg fault whenever running glute destroy window, or it's run by itself with glute close function. I don't expect any of the memory leaks you discovered to originate in FreeGLUT, but if you think there is an issue, thanks, I posted that. I do wonder if anyone has actually posted this issue. So if you just search for memory here, yeah, there's no memory issues there. Glute exit. Let's try that. So the exit function. Let's try rewriting that function and void exit. Is there documentation for this? Process loop function. Okay, no, it doesn't. And then we can set the display function. We can set GL. Sorry, GLUT. Is it exit function? What is it called? Close function. Exit callback. So now, does that remove all the resources cleanly? Let's see that. So again, we've got the window here, nothing drawn yet. And there's still a bunch of things that don't get returned. Can we destroy the window? We destroy window. I guess. No. I mean, glue exit is calling all of these already, so. Address sanitizer, Stack Overflow. Let's see if we can get an example of it. Glue close function. Example. Users looking to prevent FreeGLUT from exiting when window is closed should look into using glue set option. Okay. This doesn't help us. Let's look at the actual documentation, I guess. Close function. Callback client window destruction hook. When a window is destroyed by a user action in traditional GLUT, the application terminates. In FreeGLUT and OpenGL, the application can choose to persist and treat the window closing event as a normal event. So its callback is how the event is transmitted to the application. Function exactly the same as GL window, which has been deprecated. There needs to be some work to rationalize the behavior when a window is closed. Okay, no. I still have that no matter what, so I've got the window ID here. What if we set that as a kind of global variable somewhere? Too few arguments given to function destroy window. Let's try that now. Let's see if that looks better. Here's the window, closing it. No, it's still a lot of shit. What is the actual issue though? That's unstuck. Damn, why do all these libraries have issues with the memory sanitizer? First GLFW and then FreeGLUT. It's very annoying. Let's try a window. Seems to be functions like FreeGLUT destroy window, which matches create window and perhaps others. I have tried using destroy window and GLUT main loop with the windows. When you close the window, the program continues normal execution due to property that's set in glue set option. Once it executes, the window destroy throws another error. Call it out. First calling glue init. Automatically freeing up any allocated from the create window when I close the window. Maybe the source of the leak is elsewhere. Trying a similar code and I found online. I'm not there, so I don't know if it seems to be working, and the address sanitizer still screams summary address. Yeah, Just test without grind, and I seem to get more verbose leak. Yeah, I mean, it really does seem like we're gonna have to, unfortunately, disable the address sanitizer, because these libraries just have a, I guess, a taste for memory leaks, unfortunately. Gotta love C++, right? Gotta love C++. Don't need that anymore. We don't need that anymore. Right. What we do need to do is we need to create the shaders here. We've got compile shader. We also had an example shader here that we can use. I do apologize if the stream is quite boring. Unfortunately, getting OpenGL to work is quite boring, and it does take a while, especially if you don't know how to do it, like me. So now I understand why the Rust streams seem like way more productive than C++ ones. Well, oh hey, what can we do? Yeah, string view shader code. So okay, so just make sure there's no issues here. If the shader ID is 0, okay, so this returns a boolean. So if we don't compile, they should actually return an int, right? Or whatever this returns us, which is a jailcreate shader. I think it's an integer. Pretty sure. What's the issue? Can't overload functions distinguished by return type alone. Why would you be doing that? There you go. Now, yeah, I mean, this is fine. Well, we just need to return the shader ID. And instead of this, return 0 here. Cool. Shader code string. So we've got a vertex shader ID. Now we probably need to do a fragment shader as well, right? So let's just take a very quick one. So fragment shader example. And if you're trying to learn OpenGL, this website is really good. Learn OpenGL. It has everything that you could possibly want here, like from beginning to, I guess, not very advanced, but like intermediate OpenGL, I guess. I'm still, you know, a beginner on this, basically. I need a fragment shader. There you go. Out. Okay. So again, just gonna hard code this because I want to test it really quickly. Okay, this should work. I probably want to keep this one here too. If you're going to follow this tutorial, might as well. Okay, cool. Yeah, if you don't know, GLSL is like the language of the shaders, so it's very similar to, I guess, C++, but nonetheless a little bit different. Like you can see keywords like in vec4, so this just means like you pass into the shaders from OpenGL a vector 4, so it's like an array of 4 like doubles essentially, or 4 floats called vertex color, and then you can use that to actually kind of output the color. But yeah, it feels like I've copied the wrong thing. Location 0, yeah I did. There you go. That was looking more like a fragment shader than a vertex shader, so that's much better. Cool. Yeah, then we can do normal, I guess, OpenGL calls in here in the main CPP. So we have that, and we also have basically the same thing for the fragment shaders. Are you using raw string literals to write shaders? Yeah, just for now. I'm just first of all, good evening, Dana J. Good to see you here. But just for now, just so I can include it on the header. Obviously, in the future, I'll probably be loading from a file or something. So I'm just trying to actually get a triangle to draw today. That'll be a huge win if I can do that. Fragment shader code. Yeah. Vertex shader. Vertex shader. Here I have the fragment shader. And here I have fragment as well. And of course, I do have fragment shader ID here. And I've got fragment shader string. There you go. It should be a little bit better. Once I've compiled the shaders, what I do need to do is I need to set the shader program. So GL is a shader program or something. Shader. We'll use shader program. Use. Tell you what. We will know by looking at docs.gl. A website that I truly recommend. Again, if you're reading documentation for OpenGL, it just makes it slightly easier. Use program or something. Yeah, that's the name of the function. It's, I gotta say, OpenGL sometimes has functions that don't really match. So for compiling a shader, it's like GL shader data or something like that. And then for loading, yeah, you can see it all here basically. So you create a shader with GL create shader, and then you compile it by setting the source first with shader source, and then GL compile shader. But then when to actually use the program, I guess it's GL use program. But yeah, this kind of makes sense because you have to actually create what's called a GL shader program, where you say, this is the vertex shader, the fragment shader I want to use, and optionally the geometry shader, as you can see here. So yeah, that's what we need to do next. We need to take those 2 shaders that we compiled and then turn them into a program that your GPU can run. Is it create program or something? Compile, create program, there you go. GL create as an empty program and returns a non-zero. Again, this will probably be in our kind of like GL abstractions, right? So we have something like, does this return an integer? Yeah, GL uint. Oh, unsigned int, unsigned. So we need to create a program, or create shader program. And then we have to pass in the IDs for the, I guess, the shader, right? Before I do anything, let me just make sure that these return types are correct, because we have create shader there. Does that return a uint? Yeah, it's a uint, so it should really be unsigned int here, right? Or something. And if I go back to this one, it should really be unsigned as well, if I can spell it. So you have the shader, the vertex shader ID here. Then we have the fragment shader ID here as well. Cool. And then if I just copy this and basically define it here, what's the issue here now? Good. It's very easy. Like the plan for this is like you create the shader program, and then we set, I'm not sure if this creation program takes, yeah, it doesn't take anything. Then we have to set the vertex shader, set the vertex shader for the current program. Do the same thing for the fragment shader, set the fragment shader, and just return the program at the end. That's our thought process here. So let's see. So create shader is the first thing we're going to call. GL create shader. Sorry, it should be GL create program. There you go. I think this takes an empty, it takes void, yeah, it takes nothing. What does it return? This function returns a 0 if an error occurs. Okay, so we can basically do if, you know, the program ID was not created, if it's false, then we can say stdc out, fail to create the shader program, right? Of course, there's an issue here. And at this stage, we've got a working program. So next thing to do is set the vertex shader, right? And let's see which function we use for that. Let's see if there's an example here. So attach shaders, GLUint shader. Specify the shader object that's been attached. Specify the program object will be attached. So this attaches a shader object to a program object. Okay, so what does this return? Void. Okay, so we need to call this function. So GL attach shader, and then we've got a program ID there, and we've got our shader, so the vertex shader ID, right? Unless it's not, what does this take? GLUint shader. Oh, there you go. And we did the same thing for the fragment shader. And I'm pretty sure we have to link after that. So shader info, compile shader, we've already done that. we link the program. Yeah. So yeah, once you've compiled the shaders, you've linked them together to say this is a vertex one, this is our fragment one, and this unity is called a program, a GL program, a shader program. We have to link the program, I think. So this is what this function does. Specifies the handle of the program. So description: GL link program links objective shaders. If any shader objects of type GL shader are attached to program, they will be used to create an executable that will run on the programmable vertex processor. Cool. The status of the operation will be stored as part of the program's object state. This value will be set to GL true if the program object was linked without errors and is ready for use, or false otherwise. Okay, so basically it doesn't return the error here. However, we can query it later on. So this is a to-do for us. We don't exactly know what's going to happen if it fails straight away, but we can sort that out later, I guess. So GL link program. And then we've got the program ID there. And as a to-do, make sure there's actually succeeded, right? Because as I said, this doesn't return an error. It's kind of annoying that OpenGL functions don't do that. And then we have we return the program ID. That is it. Let's just remove all these spaces. And that's basically our function. So again, in here, we can kind of create, is it a shader program or something? What did I call it? Yeah. And we can pass in the vertex shader ID, and then the fragment shader ID here as well, right? And then we need to set this auto const program ID to that. And of course, if the program ID is none, we probably throw an error or exit the program, right? Okay, so in here we don't actually need the CL. All we do is return, just return 0 here, early return, because in here we can actually say if this was not created, then we can do a std.cl. This is why we failed to create the shader program, and we return -1 here, right? Yeah, once we have everything, we can actually use the program. So again, it's like GL use program, I think it is. So we can do that. However, if we want to actually draw some sort of like, I guess a rectangle or a triangle, we have to kind of follow this tutorial, because you have to load in the vertex data. So for each triangle you want to draw, you have to pass those points to OpenGL, as well as the colors, and only then can you render everything. So let's see how this is doing here. So GL clear, GL use program. Yeah, so we have some VAOs, vertex attribute buffers. Which is, I guess, is done in the previous page, but yeah. So these are the vertices for a triangle. Let's just copy and paste this. This is like centered on the center of the screen, I guess. You can see what it looks like in here. Let's put that in here somewhere. Why is it not copying? There you go. And if you want to sort of modernize this a little bit, yes, we could include the array header and turn this into a const expr kind of stud array of size 9, float, and then vertices there. Right? Is it float and 9 expected type? Yeah, it's the other way around. Cool. Yeah, you can see that we have to generate these buffers that I mentioned, like the array buffers and the color buffers, I guess, as well. So we're just gonna kind of, I guess, copy this slowly. But this stuff will actually be, yeah, I guess it can be outside the main loop. The main loop is the one that's actually, you okay? Huh? Is it falling on the sofa? No, I think it might have. Okay. Just looking for the, sorry about that. Yeah, we can load these buffers outside the main loop, because we can just reuse them inside the loop. So we need to create the vertex buffers. So what this is doing, this is generating a vertex buffer object for me. That's fine. I'm just going to call it VBO here though. I'll probably initialize it with -1 or something, or 0, right? Does it have to be 1? Let's see if it always generates a something more than 0. Gen buffers. Yeah, I want to see that does this always kind of return a non-zero buffer? That's what I wonder. It guarantees that none of the return names was used immediately before the call. Yeah, maybe we can't really do that. Maybe we can't check if it's, you know, I guess 0. If it's non-zero, sorry. And we also need to delete this, pretty sure. We delete buffers to do delete the buffer. But going back to the tutorial, we have bind buffers, VBO, buffer data. Yeah, we can do that here too, I guess. So we can do a GL bind buffer. If it's going to let me do that, yeah, bind buffer, GL array buffer. And then we have to put the data into the buffer as well with this function. Now for us, we have vertices, yeah, size of, we can just do this dot size here in this case. And we've got vertices dot data and a static draw. And what's the issue here though? Too few arguments in the call. No, there isn't. Expected, okay, so this is just kind of frozen a little bit. Okay, yeah, good. So it did build. So what have we done here? This is basically just like loading all of the data, like loading the vertices, right? So load the vertices into to OpenGL, I guess. Kind of giving your GPU the data so we can kind of grab it and then use this data inside the vertex shaders. That's what we're doing here. We don't have color information yet though, which is a little... Yeah, what does our shaders actually do? So the original shaders that we have. Antonio Augusto. Hello Antonio. How is it going, dude? Tudo bem? yeah, so our vertex shader takes in at location 0 the position, and it gives back a vertex color for it. So what does it actually do? Because it returns the color, it passes the color on to the fragment shader, right? Do we need to declare additional function to draw between vertices? What do you mean by that? Declare additional function to draw between vertices? Because, like, no. If I understand it well, like, no. Basically, you pass in the vertex data, and those vertices, like the triangle vertices, will kind of go to the vertex shader, and the vertex shader for each vertex is going to return a color for it, okay? And the fragment shader is going to interpolate. So like if my vertex, like the top of my triangle is blue and the bottom one is red, the one in the middle, like the pixel in the middle, will be a mixture between red and blue. This is what the fragment shader does by default, and you'll see what I mean in a second, because it will it will be very clear once you run this. All good. How about you? Yeah, I'm good too, man. To the Jabora. Yeah, once again, thank you guys for joining me. It's nice to see you guys around. So let me just understand what this is doing. So GL position. So we create a vector 4 where the first 3 elements of that vector is the position, and the last element is 1.0. See how we directly give a vec3 to a vector4 constructor. Yeah, it's called sizzling, I think. So like you can create a vector 4 size 4 from a vector 3 size 3. You would just like append to it basically. See the app. Yeah, so this is all one color. So okay, this is gonna work. So I don't need to say which colors I have for each vertices just yet, because it's gonna output the same color for all of them, right? Now I am wondering whether this is it, whether I can just compile this. Use program. So I wonder if I have to use program before I put everything in there. Like you said, the code you wrote, it just passes the vertexes to the GPU. So I was wondering if you need to write additional GL functions to draw. Yeah, you do. You have to draw. You have to do additional functions. And these are called shaders, by the way. This is what this is. This is a shader program. It's very similar to C++, but it has a few differences. It's mainly used, well, it's aimed for like graphics, mathematics for graphics. So it has like vector multiplication and that kind of stuff, I guess, made very easy for you. So, but yeah, this you hit the nail on the head there. This is what the shaders are. So when you see in an engine like that they're compiling shaders and doing whatever, this is what it means. It means that they are sort of like setting those shaders, compiling them, and passing them to the GPU, basically. Okay, so I wonder, yeah, let's see, can I actually use this? So if I do, I wonder if I have to use the shaders before or after I set a data. So bind vertex array. Yeah, we'll get into vertex array object in a bit, because this is basically a way for you to kind of keep some configurations the same. This is a bit more advanced. We're not going to do that today. I just want to draw a triangle. So yeah, it's GL use program, bind vertex array, and draw objects. Do we have to do? No, yeah, we have a vertex array object by default, so we don't have to do that. So you have to use the program and draw triangles, draw arrays. Okay, GL triangles. Okay. So if we do GL use program ID, and in my display function, if I actually, this is the only shader code I wrote was for a simple requirement, a SKIA library for a React Native project I was working on. Honestly, the shader code you wrote looks a lot scarier. Dude, this is simple. Yeah. This is really simple stuff. I didn't write this, by the way. I copied it from the thing, but it gets a lot bigger once you start dealing with, like, I guess when you have like shadow objects and What else? Like lighting. It's actually, you know, the maths is simple, but it gets a lot bigger. But it's not scary. Like once you understand it, it becomes fairly easy. Okay, so let's look at the display loop, the render loop. Because in here, I can actually do GL draw arrays, GL triangle, I think it is. Triangles. What was it? Triangles, yeah. GL int, GL count. So how many? Yeah. I guess we can hard code. We've only got 3 triangles. So let's try this. Am I claiming that this is not going to work? Absolutely not. Every time I do OpenGL, every time I get back into it, like the first time I compile things, it just doesn't run. But we can try. We can try. There you go. There's a segmentation fault. Now let's let's see where that is happening. You aren't repeating simple. I'm here too, sir. This is fucking scary. Yeah, dude, it is scary. Like even for me. And I've done all of this before, by the way. I've done it many years ago. It's still scary. Like I still get it wrong. As you can tell now, it's still very wrong. Let's add a configuration for debugging. Let's launch. And here we have. We've got build, Unix, debug, SRC audio, visualiser. That's pretty much it, right? That's all we need. Must be hard to debug. Yeah, it's very difficult actually. Debugging OpenGL is one of my worst fears. Especially because it doesn't return errors or anything, so you have to basically use callbacks to figure out where the error is. An empty like callback, like error queues and stuff. And I can only imagine it's more difficult in Vulkan, but I've never really done Vulkan, so I don't know. Let's put a breakpoint here. Okay, so why? Okay, so our window is created. It's here. Now is in compile shader. Yes, it's in compile shader. Segmentation fault. Shader type. Okay, no, this is weird. Get shader type. Huh? So there is. What? So as soon as this happens, there's a. Okay, yeah. So create shader gives me a segmentation fault. This is hilarious. This is actually hilarious. What does this return? What are these supposed to be? Maybe there's a warping issue. GL create shaders. GL enum. It's supposed to be a GL enum. It's a vertex shader. What is a GL enum? GL enum. It's just an unsigned integer. It's just an unsigned integer. So what's going on? Let's do a clean build. GL create shader. And the shader type. Oh, yeah, we're debugging, I forgot. It still gives me a segmentation fault. See, this is why it's scary, because obviously there's something wrong here that I've done in the, I don't know why or where, but it fails on create shader. So I have no idea what's going on. That's the issue with OpenGL. Let's see what we did before that though. So we initialize, I guess, yeah, we don't really do much OpenGL before that. So GL create shader, GL seg fault. That's where the biggest causes are. There you go. I've even seen this before. It's still in my history somewhere. Typical C++ programming. Yeah, indeed. You're not checking OpenGL extensions versions, so glue init. Oh yeah, it must be a version kind of thing, right? So it's probably glue is probably initializing OpenGL 2. This makes sense, you see. It's initializing OpenGL 2, which doesn't have the shader stuff. Glue OpenGL 3. Glue context version. Let's try this one. How do we do this? How is this person using it? Init context flags. It's just before the init context flags, right? Init display mode. Huh? This is not what I meant. Why can't my clipboard just copy things? Right? That exists and it's there. Let's do it straight after glue init. And let's recompile this. I forgot we are debugging still. I think it was already running before. Let's close it and open it again. Let's pray to God that this works, and it doesn't. It does not work. And this is someone who has done OpenGL before, you see. Cannot create a shader in vacuum. Must be created with a valid render context as current. Do I now have a current context? Glue init display mode. Glue context. Init context. Wait, how do I make the current context? Make the current window context. Glue context create. Context version, glue core profile. Okay, so this is basically what I'm trying to do, right? Init display mode. Glue init display mode. Maybe that's another one we should create as well. Oh no, yeah, we do have init display mode. Very fiddly, very fiddly. Let's run this again. Do we still get it? We still get it. Eh. Typical, yeah, I've already read the message. Now this is starting to annoy me slightly, because it should work. So glue GL create shader seg fault. if you're not checking OpenGL extensions, versions or not. We are initializing glue, right? Before I'm... Oh, no, we are not initializing glue. That's why, guys. That's what's not going on here. So if we do glue init, maybe, just maybe, will work. Glue init, by the way, I think is the function that kind of grabs all the function pointers for OpenGL. So he links like GL create shader to the actual function pointer where it is on my machine. And if you don't call that, it's just going to be 0. So if you call a no pointer as a function, do you know what happens? Do you? It gives a segfault, and that's why it works now. But yeah, I mean, let's see what happens here. So we create 2. Yeah, as you can see, there's no triangle here, so it didn't work. Now I wonder if this is getting called at all, though. See, this is not being called. Gmain loop. So what do we have to do? The screen is black. Is this being called at least once? Let's have a look. If it was Rust, the compiler would have yelled at you. Yeah, they would. Exactly. That's exactly my point, you know. C++ needs some work on that, I guess. So this gets called once here. We swap the buffers. Okay. But we don't call it back. So at that stage, there's nothing. It's, you know, data's probably still being passed. What if I do here GL? No, back to the tutorial. Back to the tutorial we go. So what does it do here? He uses the program. He binds the vertex array object. We don't need that because we're just gonna use the default one. And he draws the arrays here. Okay. So the vertex attributes, vertex attribute pointer. Okay, maybe we do need this. We need to enable them. There's all these little things with OpenGL that you just gotta know, I guess. I don't understand why my Control-C doesn't work unless I type it multiple times. Attribute pointer, attribute, okay. Use program buffer data, okay. Yeah, you need this call here, by the way, vertex attribute pointer, because you need to tell the GPU how to represent the data, right? Because, I mean, you pass in this, I guess, this blob of data to the GPU, and it's kind of like, you know, 4 bytes each element. Like, you know that each 4 bytes is a floating point, but you kind of need to tell the GPU that. So if you look at the documentation for it, so GL vertex attribute pointer, so GL attribute vertex attribute pointer it defines, like, once you have the data in the GPU, it tells the GPU how to represent this data or how to read this data. So you say where, I guess, it kind of starts. Which one are we using? Because there's 2 flavors of it. We're using 1, 2, 3, 4, 5, 6. The one with 6. 1, 2, 3, 4. We're using this one here. So we specify the index of the generic vertex attribute. So I guess in our case, a 0. We specify the number of components per generic vertex attribute must be 1, 2, 3. So how many components this has? If it's like a x, y, z coordinate, it will be 3. Obviously, that's why we're passing 3 here. The size of each component. So how many bytes each component has. So it's a GL float, I guess. Sorry, the type. The type comes first. I'm getting ahead of myself. The type of the component is a GL float because we're passing floats. And then the stride. Stride is basically, stride is the 4th one, right? So sorry, yeah. If it's normalized with, that's the 4th argument here. I was getting ahead of myself. And the data is not normalized, so we set it to GL false. This is like mathematics normalization of coordinates, if you know what that means, I guess. Stride is like where the next element is. So like once you start the first XYZ coordinate set, like where is the next one? So it's like basically how many bytes away is that from the first one? And that is at 0, as you can see. And then the pointer, which is the pointer to, I don't know what this is, to be honest. I always pass it, you know, as this. I guess I should explain here, right? It specifies the pointer to the first generic vertex attribute in the array. If a non-zero is currently bound to GL array buffer, target pointer specifies an offset into the array in the data store of that buffer. So this is saying that if there is a GL array buffer bound, so as you can see here, there is one bound. If we pass in 0 here, it's just going to point to this data here, right? So this is kind of what it means. Yes, it's scary. I'm not going to lie. This documentation is very scary, but what can we do? My other problem is that this GLUT display function is only being called once, right? So GLUT display function only called once. Add a timer supposed to redisplay every now and then. Okay, so we need to, I guess, post a timer. Alright. Otherwise, display will only be called when the OS feels like it, usually after an exposed damage pane event. So we kind of got to tell GLUT that we want to call the display function every, like, I don't know how many times a second. Say we aim for 30 times a second. How much is that? So we divided 1000 milliseconds by 30. How many milliseconds? Around 33, right? So how do we do this? We define a timer, and then GLUT display function, display, GLUT timer, timer function. What's in the timer function? First, okay, so let's just do this, I guess, right? Let's just copy and hope that it works. GLUT timer function 00. What is this? Unsigned time, callback, and the value. I still don't know what this is, so let's look. GLUT timer function. No, I want the actual documentation. Where can I find that? Can I find that anywhere? Okay, this one. It takes 3 milliseconds till invocation, callback, the client callback, and data. Arbitrary data passed to callback. Okay, so we don't want any data, but we do want to set it to 33, right? So we want to set it to like 33 here. And this is just the data that's going to get passed in, I guess. So now we can do, I guess, a GLUT timer function. So unsigned in 33 seconds, we're going to call that. We're going to call it as a timer, and the callback is done. Wait, what? The data is just 0, right? Now, is this going to work? Post redisplay. So yeah, do you guys get it? It's like, essentially, it seems like GLUT only calls the render function whenever it feels like it by the OS. So there is this timer function that actually calculates next time. Well, it's just a timer function, right? So it runs every like 33 milliseconds. But if you put this function here, it will redisplay. It will call the display function. So essentially, every 33 seconds, we are displaying the function again. Now, does that work? I would like to know. I mean, yeah, it seems to be called every 33 seconds, which is good. But still, we have no data here. Still, we have nothing. And I don't really know why. So let's try and figure out. And this will be mostly my OpenGL, or the order that I did things here. The vertex shader allows you to still a black box. Yeah, my main issue is that I had to swap GLFW for GLUT because it had a memory address sanitizer issue. But it turns out the GLUT also has that, so I just had to disable the address sanitizer, you know. Typical C++ libraries. The delete shader, we use the program. But yeah, you don't forget to delete the shader objects once we've linked them into the program object. We no longer, oh yeah, so we can do this as well. We can delete the shaders. So the vertex shader allows us to specify any input we want. Yeah, this is what I was explaining before. Things that I still remember from my OpenGL times. So with this knowledge, we can tell OpenGL enable vertex attribute 0. The function vertex attribute has quite a few parameters, so let's think carefully. Let's see if everything I said actually does make sense. The vertex attribute is a vec3. Okay, cool. Now enable vertex attribute array 0. Vertex attribute array. Now that it's specified how OpenGL would interpret the vertex data, we should also enable the vertex attribute with GL, given the index. Okay, from that point on, we have everything set up. We initialize the vertex data, set up a vertex fragment shader, and told OpenGL, yeah. So, in theory, this is all we need. The bind buffers here. We have the vertex attribute pointers straight after that, right? So we just do it outside the main thing. We enable it and then we use the program. Now, why is this not working? So we GL clear. So we set the clear color to black. Let's set it to red. And then we clear the screen, so we set the whole screen to red, and we should see that in here now. You see that the screen is red now. But we still don't see the triangle, which is a little disappointing, isn't it? So there's something I've done wrong here. Black box, red box, finally progress. Oh no, that was the easy. We could have done that ages ago. Yeah, I mean, definitely gonna use this later, but like, what the hell is going on? Why is this not working? So GL draw arrays. We haven't even got to the difficult bits of OpenGL, yeah, like setting up multi-instance drawing and that kind of stuff. So enable vertices object. So we are passing the vertex data, right? So vertices, yeah, we've got floats in there, and we're passing the data as a static draw. It means that the data doesn't change. We're passing that many in here and a VBO there. Bind buffer GBO. Okay, so what is going on? And this is, yeah, this is index drawing, is a step up from where we are now. We don't want to do that. I just wonder, what does that shader? Is it in the shader code by any chance? So we have location 0. So whatever is set into location 0 will be our position attribute of this. And what do we have in the main? Yeah, we have index 0 as well here. 0 there. Enable vertex attribute array 0. Alright, wait. This person has enable vertex attribute. Yeah, we do that before we use the program. What happens if I do this up here? Display function. If I do something like gout enable vertex attribute array 0, right? That's what we had here. Attribute pointer. Wait, what's the difference between these two functions? Vertex attribute. Let's make some progress. GL enable vertex attribute array. It specifies the index of the generic vertex attribute to be enabled or disabled. Enables the generic vertex attribute array specified by index. So we have a nice example here. Let's see if this example, what they do. So they bind the buffer to vertex buffer, and they have the index buffer here. We don't really care about the index buffer. We haven't got to that stage yet. I'm scared I'm gonna get a copyright claim. This sounds like a good song to be in this playlist. Text coordinate. So vertex attribute pointer. Draw elements. Okay. It's attribute. Vertex attribute array. Enable vertex attribute. Vertex attribute array. And why do we call this as well? Vertex attribute array, yeah. Let's do a clean rebuild. Let's see if that makes any difference. Well, it won't, because if we could see the triangle, it would be red, right? According to our shader. Kind of red. So we still can't see it. Oh gosh. Let me think. Let's see what we're doing wrong. OpenGL, triangle, example. I just want to see a whole example and see what I'm doing wrong, because obviously I'm definitely missing something. Yeah, okay. Here, so this person has vertex shader. Basically the same thing as us. It seems like they've also copied it from the, the Learn OpenGL website. Yeah, they've just copied it from there. But they've got a create window. They're using GLFW here. Not create window at all. So they make the context the current. That's fine. They initialize GLAD, which is the same as glue. So they create a shader. They set the shader source, compile the shader. Fine. They create a shader here. Compile the fragment shader, fine. They attach the shaders, right, like we do, and they link the program. Cool. Now they've got gen vertex arrays. Ah, maybe that's what we're missing. And gen buffers. So what is vertex array done here? Vertex, bind vertex array. Maybe that's what we're missing. So gen vertex arrays. They're using the vertex array object, which I didn't really want to get into this video, but maybe it's necessary. I thought it would bind it to a default one by default. See, again, it doesn't work. If I just copy and paste once, so what should this be? This should be a gl uint. Gen gl gen vertex arrays. It's gl uint, so it's an unsigned integer. And before we do any buffer stuff, we bind the vertex array, right? So gl bind is a vertex array, vertex. Right, that's bind vertex array, yeah. Miguel. Hola, Matt. Hello, Miguel. How's it going? Good to see you, dude. Good to see you. Back to C++, yeah, back to C++ today. And hopefully trying to get a triangle drawing on the screen. Still no luck, guys. Still no luck. So, what are we missing though? Like, enable vertex attribute array 0, which is this one here. I'm just gonna copy and paste this entire thing. So we use the program, we bind vertex array. Oh, we bind vertex array after we use the program. So gl. I guess we need to basically pass in the program ID, right? So we've got program ID there. what is the program type again? It's the unsigned integer, yeah. So up here we create unsigned int shader program ID. I'll set it to 0 for now. So we use the program shader program ID. Bind the vertex array. And bind vertex array to the vertex array. Again, this will be something in here. Where's the vertex array been created? And the vertex array is here. Right? Yeah. Like this is exactly the same as what she has now, except we have the addition of this vertex array objects, which I didn't really want to get into it because I know for a fact that OpenGL has a default vertex array at the start, but I wasn't sure whether you need to actually bind it. That's the only difference that we have here functionally before you draw the arrays. But yeah, I guess we'll see now. Bind the arrays and swap buffers. Draw the arrays, swap buffers after. Okay, cool. Yeah, Git will swap the buffers for us. Okay, JFW. If this doesn't work, I kind of give up. It doesn't work. Does not work. It's not an issue with my indices either. It's not an issue with the indices. So fragment shader ID. It could be an issue with creating the shaders, right? I guess. Are they not being created properly? Let's see if we get any of these errors. Then we kind of know that the shader is the problem. Maybe a... No, does work, does work. Nothing in the debug console either. So it is just the OpenGL code that's missing something. So buffer data, bind buffer, buffer data. Got bind buffer and buffer data here. So bind buffer. Vertex buffer, buffer data. Where's this vertex buffer being used after this though? Have you linked to the libraries? I've linked the libraries. Do you mean you want the link? You want to know which libraries I'm using? I can just post the Conan file here. These are the libraries I'm using. OpenGL wants to link. OpenGL is already linked. You know, these are the libraries I'm using from Conan. I'll just paste it here. There you go. Yeah, Miguel, I guess you do OpenGL, right? So you know what's going on here. I'm doing something in the wrong order, and I don't know what it is. So I've got some vertices objects being passed into OpenGL. I enable the vertex attribute array here though, but that has to be after I enable this, right? I guess. I'm using the estimate, which is like glue. Ah, okay, cool. I see. Oh yeah. If that's what fixes it, I'm gonna kill myself for a simple project. That sounds nice though. Oh, it still doesn't work, guys. I thought the ordering of things would clear things up, but not quite. They both work as an interface, yeah. I'm using FreeGLUT, which is, I guess, is just a window and event polling stuff, but glue is bringing me all the OpenGL stuff. So bind buffer, we've got vertex array bind buffer data. So we've got gen buffers, bind vertex array, bind buffer. We've got bind vertex array, bind buffer, and buffer data. And following that, we've got vertex attribute pointer and enable vertex attribute. Vertex attribute pointer and enable vertex attribute, okay. And then on the actual function, they've got using the program there, binding the vertex array and drawing. So on the actual render function, I've got using the program. Can we go back to wherever we were? Okay, yeah. So using the program, binding the vertex array and drawing. So we use the program, we bind the vertex array and we draw. GL triangle 0 to 3. GL draw arrays. GL draw arrays, GL triangle 0 to 3. This is so weird. I have no idea why this is not working. Absolutely no idea. I will probably have to do this offline and make sure that it somehow works. Let's just... It wasn't because the triangle was kind of red, right? What's the issue? Does not exist. What? I'm confused. What the hell? Yeah, no, it's still black screen. Still black screen. Dude, this song is way too much for me right now. There you go. Sorry about that. I feel like I'm a monk somewhere in China learning Kung Fu. Does glue ask you to set position before drawing? It does, yeah, it does. And you have to set it, I guess. I put it on 100 and 100. It's alright. I don't think this has got anything to do with this issue though. I just don't know what's going on. Just don't know what my triangles are. Maybe we'll have to get the errors in OpenGL to see what happened. So we've got gl enum gl get error. Alright, so what we can do is we can create a function that will just get the errors over and over again and put it after every single call to see what's going on. Very lazily. I guess this is what we're gonna do here. Ooh. And I'm gonna call read errors after every single GL call, and then we'll figure out a very lazy way to kind of get the OpenGL errors. And someone asked me if it's a nightmare to debug this. This is why, because you gotta like unwind the error stack. There's no breakpoint or anything you can set in OpenGL. So let's try this. Let's put a breakpoint there though. It'll be something very stupid, something very, very stupid that we're missing. There are no errors. Isn't that great? There's no errors. So how? So we're just missing something. We are literally just missing something. Glue, GL, draw, array, not working. Let's see if anything I'm missing with glue. We're not using shaders. I assume one cannot use GL enable vertex array. What you can do instead is GL vertex pointer. Something like this should do the trick. Enable client stay. No, no, no. You don't want this. Could it be on my draw stuff? So if I do here, like read errors, and then we've got the read errors here, and read errors here. Let's see. Huh? Oh yeah. Of course, in C++, you actually have to define the function before you call it. It can't be later on in the file because it thinks it doesn't exist. I gotta love it. Yeah, no errors in actually rendering it as well. Oh god. Give me strength, give me strength. So what are they doing? They are drawing points. Enable client stay. What's the space bin? Is it still there? Oh, this is actually a lot of code. I don't want to read into it right now. And glue it rather. Yeah, guys, I have no idea why this is not working. As far as I know, we have everything we need. So we create the vertex buffer. How long have you been studying C++, Pablo Picasso? Hello, Pablo Picasso. Firstly, welcome to the stream. Thank you for watching. I've been working in C++ for over 5 years now, so yeah, I'm studying it before, maybe like a year or two, before I started working in it. I used to do a lot of Python before C++. And yeah, as you can see, I still struggle with OpenGL. So yeah, we've got the buffer objects, we've got the buffer data here being passed in. We set the vertex attribute pointer and the enable vertex attribute array after that. Attribute. And on the actual drawing function, we just bind the vertex array and we draw it. So what the hell is going on? Can we somehow get the whole code in here at the end? Oh no, yeah, this has a lot of comments. So we bind the vertex array, bind the buffer, passing the data, passing the elements. This is for the index draw later on. Vertex attribute pointer, and then enable vertex attribute array. Bind vertex array, bind vertex array. That's what we're missing. Oh yeah, we do have it here. Let's see what this is. Oh great, this is quite a long time. Yeah, not as long as some people I know. I've met guys that have been doing C++ for decades sometimes. So I definitely feel like a beginner still. So yeah, this exists. Vertex attribute array does exist, and it's 1. So it was set from 0, right? Because we started at 0. Yeah. And yeah, we still have a black screen. We haven't even started dealing with like the model view matrices and stuff, and we're already struggling. This is embarrassing, guys, to say the least. Very embarrassing. Glue GL draw arrays. Not drawing. It's kind of making me think that maybe it's something with glue that I'm missing, you know. Maybe I'm not setting the current window. Glue make window context. There is no gluten here. Glue create window. Does this set the context? Each created window has a unique associated OpenGL context. State changes to your window's associated OpenGL context can be done immediately after the window is created. Display state for a window. Okay. So this is setting the window as the OpenGL context, so we should draw all in there. And I have no idea. No. Let's maybe spend another 5 minutes on this before we give up. Let's see if there's any. What are these guys doing? So we bind buffer vertex attribute pointer 0. We enable vertex attribute array 0. GL clear color buffer bit. Glit swap buffers. GL disable vertex attribute arrays. It's kind of similar to what I have. Display function. With display function, render scene, which is this. Create vertex buffer, and the main loop goes in here. Should it look like that? Yeah. The other, I have to specify a vertex specification functions for each. Yeah, this. It's up to you to use the attributes the way you want. Or shaders which are explained in chapter of your tutorial. But it's definitely not the shader, right? Yeah, it's not. Because it just passes the vertices. Ooh. This is not bringing me joy, guys. Not bringing me joy. It's making me very frustrated. Yeah, we use program bind and draw. I don't think that staring at this for much longer is gonna help me fix it, so I might call it a stream, guys, unfortunately. Another failed stream. But we're getting a step closer to the goal, which is to have some bars on the screen. But we're very much stuck with the OpenGL at the moment. Because ideally, I would have a triangle by now, but I'll try and get that done by the end of next stream. Main issue is that obviously we don't have a triangle drawn in here. It's very, very frustrating. Even though we seem to have everything, there is definitely like one obscure thing that I'm missing. I quite honestly don't know what it is, otherwise it would be fixed by now. But yeah, guys, I'm gonna call a stream here today. Thank you for watching though, and if you're still watching and you haven't subscribed, feel free to subscribe. I tend to stream most days, except like Fridays and Sundays. But yeah, thank you for watching, and I promise the next stream I will have something working before I even start the stream. So let's go with that. I will brush up on my OpenGL because, as you can see, I've forgotten everything. Like, I last worked with it maybe like 3-4 years ago, I think it was. Can I send you music later? Yeah, man, of course you can send me music, Miguel. Is it yours? Like, did you make the music yourself? Because I would be quite willing to hear that. I didn't know you play music. But yeah, yeah, feel free to join the Discord as well. I'm always there if you guys want to talk to me. And aside from that, guys, that is it. I'm gonna call this stream here. Have a good night and bye bye.